So our notes today are 8.1, so chapter 8, section 1, still in unit 4. Our topic is estimating a population mean. So although you have all calculated these lovely sample means based on samples of size 25, we do not know the population mean, meaning the mean of all of the runners in this box. There are 975 runners. And so, a lot of times, and that's the case a lot of times with different surveys that we conduct, we don't know the population mean because we might as well be doing a census, right? You don't need to. So, one way I'm going to show you today to estimate the population mean is to create what are called confidence intervals. Okay? And what a confidence interval is basically a mean with a margin of error, plus or minus what's called the margin of error. Now, confidence intervals, the word confidence is actually clarified by a percentage. So we're going to start in this lesson today, we're solely focusing on a 95% confidence interval. So for a 95%, you do want to write this down, confidence interval, we would do our mean plus or minus 2 sigma sub x bars. Okay, so if you recall, just like thought bubble from what we did with the empirical rule, recall x bar was in the middle, right? And when we went up 2 standard deviations or down 2 standard deviations from the mean, included in that range, 2 standard deviations, that was 95% of the data. Remember 68, 95, 99.7? So similarly, when we create this confidence interval, we can be 95% confident that the actual population mean would fall in this range. So let's do an example. You all gave me these sample means. So for x sub 1, I'm going to calculate the confidence interval. So the 95%, and we abbreviate confidence interval with CI for x sub 1. So we know that the x bar, it's x bar sub 1, is equal to 247, I'm going to round to the nearest hundredth, 0.05, and the sigma sub x bar, we learned that equation, that formula last week, is where we just take the standard deviation of the population divided by the square root of n. So I actually do know the standard deviation of the population, and in this course that will always be information that's given to you. So the standard deviation for our population is 45.21, and the n value is what? 25? That's the number of runners you had in your sample. So sigma sub x bar, if you have a calculator, you're doing 45.21 divided by 5, right? Square root of 25 is 5. Okay, I'm going to round it. So 9.04. So I'm going to take my x bar sub 1 plus or minus 2 of these sigma sub x bars. In other words, 247.05 plus or minus 2 times 9.04. So that means I'm going to subtract 2 standard deviations and add 2 standard deviations to and from the sample mean. So you'll get 2 numbers, and you'll write them in parentheses with a comma in between. The lower number goes on the left, the higher number on the right. So I like to start by subtracting. So I would just enter in your calculator 247.05 minus 2 times 9.04. What'd you get?
228.97.
Thank you. And somebody else grab the upper bound on that. So 228.97 would be the low end. What did you get for the upper end? So that's where you would do plus 2 times 9.04. What'd you get? 265.13. All right, good. And so now we have an interval, right? So what that looks like, how we could display that visually. So I'm going to put 200, 205, 210, 215, 220. I'm not going to have room, am I? That was a bad idea, huh? I'm not going to have room for 260. Sorry. I'll try this again. Here. 210, 220, 230, 240, 250, 260, 270. So this is 228, almost 229, so that'd be right about here. So I would put a dot on the left, on the lower bound of that interval, and then 265 would be right up around here. I put a dot, and to represent a confidence interval, it's just a horizontal line. It looks like a line segment back from geometry. And that's your confidence interval. We'll do one more. So we'll do for x bar sub 2. So 250.15. We've already calculated the sigma sub x bar, so that kind of saves us a little time. So we're just going to do 250.15 plus or minus 2 times 9.04. So again, you want to do the minus first. So go ahead and calculate that. So you're going to do 250.15 minus 2 times 9.04. So again, this value right here, the 18.08, is your margin of error, right? That's kind of the amount of cushion that you need in order to be 95% confidence that the population mean is going to fall somewhere in between these two dots. What'd you get, Lainey?
232.07.
What'd you get, Shelby, for the upper?
268.22.
Thank you. So that's 232, so that's going to be somewhere right around here. Again, make a new line segment up to 268. A little further out here. What do you think? Do you think those two segments are about the same length? Should they be?
Yeah.
They should be. Since we're adding and subtracting the same value. We're adding 18 essentially and subtracting about 18. So they should both be about a length of 36 units. Okay? And we could go through each of these sample means and continue to calculate our confidence intervals. And then ultimately we would say, well, what is the actual population we could estimate? So since I'm 95% confident, if I had 20 of these line segments, the population mean would likely go through all but one, right? So we'd have this one confidence interval that wasn't included. But otherwise we would have the 19 other confidence intervals would include this dashed line that represents the population mean. All right, I'll continue these notes in the next video, which you can watch tomorrow on your flex day.